Hi guys, I'm live. How you guys doing? I think it's time for a math lesson. If you don't want to, then just don't join me. But if you do, here we go. Math lesson time. I got these new markers. There's 6 of them. There's black, purple, pink, orange, green, and blue. I think I'll start with black, and let's see if I can do this. I want to try to give you guys a math lesson, okay? I haven't done math in a while, actually since the last video I did with you guys. That was the last time. When you saw me do math on my video, that's the last time I've done math. So if you have dy dx, that's the derivative of y with respect to x. But what if y equals a function of u? Y equals f of u. And u equals f of x. So you're talking about y equals a function of u, but u is a function of x. So you're talking about a function of a function. Now, this isn't a formal proof, but logic says, it's at least that it's reasonable, that if you want dy dx and y is a function of u and u is a function of x, it's logical to say that dy dx equals dy du, which is this, times du, can't even run a u, can I? Times du dx. In other words, if you want dy dx and y is a function of u and u is a function of x, dy dx is dy du times du dx. The du's kind of cancel out to give you dy dx. That's not a formal proof. In fact, that doesn't prove it, but it shows it's likely true, and it turns out it is true, and that's called the chain rule. Chain rule in calculus. So there's that. We're either going to do the chain rule only today, or we're going to do the chain rule and one other thing today. We'll see how much far we get and what we can do. So let's do an example. You can't do much in math. Just examples really help in math because they help you work out your problems with the problem. You know, if you never try a problem, you don't know what your weakness might be. It's like if you're a martial artist, you actually have to fight. You can't just study it. Okay, so let's make. I'm going to go with this book example. You know, I'm not literally following the book, but I want to do the same example as the book, so that if I get in a corner, I'll see. I'll have a better chance of getting out of it. So we're going to do. We want dy dx, where y equals the square root of x squared plus 1. Yikes. That's a mess. If you just try to do it directly, you got all kinds of problems, you know, already. But we're going to do this. We're going to say we want dy dx. This is what we want. Y equals this. We're going to say that y equals the square root of u of x. And we're going to say that u equals x squared plus 1. So we're going to make x squared plus 1 equal to u, and then y equals the square root of u of x. And we want dy dx. So we're going to use the chain rule, which says dy dx equals dy du times du dx. I wish that were a simple proof. That would be nice in math. But usually there's a hiccup when something's too simple and you got to use a more rigorous way to actually prove it. But it does seem logical by inspection. So that's what we're going to do. There you go. We're going to do dy du times du dx. So now that we've written that, let's erase some of it so we have more room here. I think we've done a lot of the hard stuff in calculus in my videos already. A lot of it coming up is easier. it's the concept. It's the foundation. It's often the hardest stuff. Get past that, the rest is just, it gets easier after that, you know? Okay, so let's do it. So u equals x squared plus 1. All right, let's start with that. We're going to want du dx, so we have du dx by the power rule equals 2x. That's just the power rule. Okay? But then we have y equals square root of u. But that's equal to u to the 1/2 power. Using the power rule, dy du dude, don't ask me to be a graphic designer, I would flunk. Dy du equals, by the power rule, equals 1/2 x to the minus 1/2. Just the power rule. Okay, we're getting somewhere. Because let's conveniently erase this part. We don't need it. We already did that work. All right, and then we have so we already did this. So now we have dy dx equals dy du times du dx. Looks good to me. That's equal to 1/2 x to the minus 1/2. That's dy du times 2x. Yeah, dy dx equals that. Don't need this. That's just in the way right now. So that's our answer. But I'm going to simplify things a little bit. That's not it's a very messy looking answer. So I said 1/2. So it's dy dx. I can never write an x. I always write one of the bars in the x the wrong way. Equals x to the minus 1/2 is actually 1 over the square root of x. Because x to the 1/2 power is square root of x, power over root. And since it's negative, it's in the denominator. So x to the minus 1/2 equals 1 over square root of x, but 1/2 puts the 2 in the bottom. So 2 times, well, that was weird. Let's do it like this, times 2. I'll make it a little explicit there. And then the other 2x in the numerator. So that so then you have, instead of 1, you have 2x. So that looks like our answer so far. Hope I did this right. And then dy dx equals, the 2's cancel, so you get x over the square root of x. And that would be x times x to the minus 1/2. Here, let's not do it that way. Let's do it like this. What would you do there? Let's multiply both top and numerator and denominator by square root of x. That works, I think, I hope. That comes out to equal x. That comes out to equal, I'm running out of room. That's the only problem right now. I gotta make room for this. So let's dy dx, let's move it over here so I have more room. dy dx equals, x over square root of x. Multiply both top and bottom, or numerator and denominator, by square root of x. I write like crap, of course. Square root of x. This equals x in the bottom, And this on the top equals x times the square root of x. The x's cancel out. So the answer is just the square root of x, I believe. I'm going to check the book. Square root of x. So if y equals x squared plus 1, no, if y equals the square root of x squared plus, if y equals the square root of the quantity x squared plus 1, then dy dx equals square root of x. Please, I hope I did that right. If I didn't, then mess up me. But I did it right. I don't know if I did it right or not. Let's see if I look at the book to see if they have their example here. I might have messed up. Don't tell me I messed up. Oh well. Oh, I know what I did wrong. At least I'm learning. Okay, I think I did goof. Let's try it all over again. Sorry about that, guys. I think I messed up. Which I did. I haven't done math in a while, and I'm rusty since I. Okay, sorry about that, guys. Let's try it once again. It's like, okay, so why does it go to that? Da, 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 da. So let's try again. So I have u equals x squared plus 1. Yeah. X squared, u equals x squared plus 1. Let's start with there. du dx equals 2x. That's du dx is 2x. But y equals square root of u equals u to the 1/2 power. See that one messed up? Which means that y equals 1/2 u to the minus u to the minus 1/2. That's where I messed up. Which means equals 1/2 square root of u. See that? That's y d. Yeah, that's dy du is that. Du dx is 2x. So making room up here. Therefore, dy dx equals dy dx equals du dy du, which is 1/2 square root of u, times du dx, which is equal to 2x. See, now I'm talking turkey. But u is x squared plus 1. So the 2's cancel out. So I get x over square root of u. But u is x squared plus 1, so that's equal to x over square root of x squared plus 1. That is a derivative of, that is dy dx. X over the square root of x squared plus 1. Yay, I did it. I'm not a bonehead in the end after all. So x over the square root of x squared plus 1 is the derivative of the original function, which was square root of x squared plus square root of the if y equals the square root of the quantity x squared plus 1, then dy dx is x over the square root of the quantity x squared plus 1. That's a good example of the chain rule. And we actually did it right. So very good on us. Very good. You want to do another topic? Or is that enough for this? Or do you want me to add another? I think we want one more topic. We're on a roll. We're also on a biscuit. You get that joke? We're on a sandwich. I got that from Billy Crystal, though. He's the one that did that first. He said on a literal roll and said, I'm on a roll. I'd already thought of that, though, but he's the first person that did it famously. I didn't do it famously. I just did it in my head. All right. Do you want to do another topic? I'm trying to think if we want to do another one if we're done. Let's think about it. Let's see if we want to do another topic or if we are done. Chain rule, chain rule, chain rule. Thinking. Let's leave it at that. Love you guys. Peace, love, and rock and roll.